So this is problem number 31, exercise number 31, and it's similar to number 31 in section 3.2 in the book. It's just that a couple of the numbers are changed. That's all. So let's see what we can do with this. What we're asked to do here is find how many tubes of each food should be supplied. And as you read through this, it looks like there's two foods, right? As you read through, it's in the first sentence here. He's considering a combination of two foods which are packaged in tubes. And then as we read further, there's food A, and it's got some things in it, and then there's food B. And what we want to know is how many tubes of each type. So let's start here. Since we want to know how many foods of each type, why don't we do this? Why don't we let X equal, so what we'll do is let X be the number of tubes of food A, and Y be the number of tubes of food B that we're going to use. Now let's just try to set this problem up. Our categories are going to go across the top here. We have food A, and we have food B, and then we have totals. Those are our categories. And then down the side here, I'm going to put the characteristics. So what we have in each food is protein, carbs, and fat. So we have protein, carbs, and fat, and then there's a weight. So we'll set it up like this, and just by reading through, we should be able to fill these numbers in. Now, the problem tells us that each tube of food A has 4 units of protein, 2 units of carbs, 2 units of fat, and weighs 3 pounds. Each tube of food B contains 3 units of protein, 6 units of carbs, and 1 unit of fat, and that weighs 2 pounds. Now, the diet calls for 42 units of protein, but what we need here is we need at least, so greater than or equal to 42 units of protein, 30 units of carbs, so we need at least 30 units of carbs, and at least 18 units of fat. That's not it. The requirements say that we need 42 units of protein, but we're not going to get exactly 42. We need at least 42, right? That has to be greater than or equal to 42 to meet that requirement. At least 30 units of carbs and at least 18 units of fat. So I think we have everything we need to set up this problem. What we're trying to do here is we want to minimize the weight. So what we want to do is minimize 3x plus 2y, right? See where that's coming from? We've got that last row, the weight row. 3 of those, 2 of those, subject to these constraints. So our first constraint is this first row right here. And what we'll have is that 4x plus 3y greater than or equal to 42. The second row tells us that 2x plus 6y greater than or equal to 30. And the third row is 2x plus 1y, just y. That's greater than or equal to 18. And of course, it has to be the non-negativity constraints, that x is greater than 0, y is greater than 0. And here is our problem. We've set it up, and now we could solve it by graphing. But we'll just set it up for this case and move on.